And welcome back to yet another episode of Learning with Junaid. Today we are going to be talking about a sorting algorithm. Let's talk about a bubble sort. Before I show you an implementation of a bubble sort, I want to actually show you a diagram that helped me understand bubble sort much faster. So this is from the book from Michael Watt. She wrote a book, I think she or he, I don't know, Michael Watt, a good book on data structures, very old book. So I'm going to open the diagram. I just copied it, so in case she sees this algorithm or he sees this video, I would like to thank the person. So basically, the diagram goes something like this. If you had a baseball team with these heights, if you see here, so what do we want to achieve from bubble sort? We want to be able to achieve this. We want to achieve the largest at the end and the shortest at the beginning. So that's what it is. So the rules of bubble sort are very simple. So what the algorithm says is compare the first one with the second one. If the first one and the second one, if he is greater, then swap them, and similarly do the second one with the third one. And finally, at the end of first pass, you would have gone through everything, and the longest person will be at the end. So that's the first pass. In the second pass, you will do the same thing, but this time you will not, you will start from here, but and then you will end here. So that's the algorithm. So let's see how we are going to implement the bubble sort. So I'm going to go open a program, and I'm going to first, let's say I want to first display my true dot for each. I'm going to say dot out dot println, and then let's just display the values, the unsorted values, so that we know what happens. Okay, so when you display it, you obviously have a unsorted one, right? Okay, so that's good. So we want to be able to now pass this array to a method. Let's call the method as bubble sort, and then let's pass this array, and then let's just write the method. So when you write the method, I am going to be passing back an array that is sorted. So let's say, so for now, return just whatever the array was passed, I'm going to return it. So the idea behind a bubble sort is, as I said before, so you have this document, you pass through each of these elements one by one. Sorry, you pass through each of these elements one by one, and then you keep going until you go to one pass, the first pass, and then you will have the tallest person in the end. Next time you start the same process again, and you go through until you come here. The first pass, this will be the tallest element. The second pass, this is the second tallest element, the third tallest element, and so on. So finally, you would have, if you have passed through everything, you would have a array like this, a sorted array. So let's see how we are going to be doing it. Let's maintain an index. Let's say there is an inner index. I'm going to do an inner index for the swapping in itself. 0 inner index is less than size minus 1 inner index plus plus. Oh, I need to charge my Mac. Alright, so I have this, this. So let's see the size. The size, I'm going to declare a variable called array.length, and then I'm going to say this is my size. Okay. What do I have to do? I have to actually now compare the element with the next element, but there is one scenario that I have to also take into account. I also have to maintain some kind of an outer index so that I know when, I know in this case, when to stop. For example, as I said in the first case, I should make sure that I stop here, and then my next iteration it should start here and come until here. The third case, I should stop here, the second element, so it has to iterate through it and come. So I have to maintain two loops. One is an outer loop also. So for outer loop, outer index equal to 0, outer index is less than, let's say I'm going to maintain the same thing, size -1, and outer index plus plus. So now I will have this thing, but see, when the first time this loop occurs, I have to make sure that I have counted for the most largest element at the end. So what I will do is, instead of doing this part, I will say out size minus outer index minus 1. So as my outer index keeps incrementing, I will go ahead and work on the inner index. So if I have to write it down very clearly, I will say this like this: the outer loop represents the number of swaps that are done for the comparison. The inner loop is actually used to do the comparison of data. So at the end of the first inner loop, what should happen? At the end of the first inner loop, the largest value is moved. At the end of the first inner loop, the largest value is moved to the end of the array. In the next iteration, the second largest value is moved to the second end of the array, the second most end of the array. So does it make sense? It's a little tricky to understand. So the outer index, obviously you will have to maintain two loops. The outer is just used to represent the swaps that are done for the comparisons. The inner is actually used to do the comparison itself. At the end of first one, we will actually have the most largest value at the end of the array. The second one, we will have the second largest value at the second largest just before the largest element of a array. So how do you do that? It's a pretty simple implementation. What you have to do is you have to check here now if my array of inner index, if that is greater than my array of inner index plus 1, you swap the values. If you know for sure that you have here, if this and this, if this is greater than this, then you just swap the value. So that's what you are going to do. You will write a method called swap, and then you will say swap, I'm going to pass an array, and I'm going to pass the indexes which needs to be swapped. I'm going to say inner index needs to be swapped with inner index plus 1. So go ahead and define this method. Now you come here, what do? You say, okay, take the value of inner index, I'm gonna name it I, and then I'm gonna name it j. So take the value whatever was there in I, put it into a temporary variable, take the value of whatever was in your j, put it into your I, you just swapped it. Then you have to now you have array of j, in this you have to put your temp. So you just swap the values if they are greater. So that takes care of your first part of your array. So go through it, and then the first pass, as I said, it goes to the first time and then this is what you would get. The first pass, this is what you would get, the largest at the end. The second time, you know, it would the second time you see this loop, size minus outer index minus 1. So the second time it will just go through right before the last one. So let's go ahead and run this program. Oh, let me just add one. I'm going to say after bubble sort, okay, so the first time before sorting it is like this. The next time when you have sorted out, you know, you would have a sorted bubble sort. It's not a very efficient algorithm for sorting. As we move forward in other sorting algorithms, we will see there are better ways of sorting it. But if you have any questions, just I would just go ahead and look at this diagram again in the beginning. This helped me really understand the implementation. And once you understand the outer loop and the inner loop concepts of it, it becomes much more easier. So just maintain. So if you see now you have two outer loops, obviously, you know, the complexity is like, you know, n square now, O n square. Not one of the most efficient algorithms, but nevertheless it's nice to know if you are working on any kind of a sorting algorithm. Basically bubble sort is one of the most basic ones, so it's nice to know a bubble sort algorithm. Again, pretty simple. Iterate through the elements until you come to the element that has already been sorted, the last one, and then just if you find they are, compare it. If one is less than the other one, or one is greater than the other one, just swap it. Pretty simple algorithm. That's it for now. I think, you know, we will move on to the next sorting algorithm after this. Thank you so much, and I will see you soon.